All right, now we're going to talk about histograms using that same data set we've been using. If you didn't watch the other videos, I just made up some random numbers and I said this was the amount of free throws that 16 people in the class were able to do in like 30 seconds. Okay, it's completely fictitious, so take it for what it's worth. All right, so like I said, there are 16 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So n is going to equal 16. 16. That's a really weird 6, but it works. Okay, so now to make a histogram, you need to figure out, you need to make bins. You need to make bins. All right, think of it like a bin that you put stuff in, right? Because we're going to take groups of numbers. Like we're gonna sort these numbers in to like a range, and then those bins are going to represent that range of numbers. Okay, so so how many bins do I need? Well, it's if I take the square root of n, so number of bins. A good approximation. There's a more complicated one for this, but if you round the square root of n, that's going to give you your number of bins. All right, so number of bins I need for this is the square root of 16, which is 4. Now, if you're given something that's in between 4 and 5, or in between two numbers, kind of look at the data and determine the bins that you need, right? And you'll make the bins to be about the same. Oh, they are going to be the same size. So I need 4 bins, right? So 4 bins I have, let's see, there's 10 to 32. So 10 minus 32 is 22. And we're going to divide 22 by 4. Okay, so the range of this number is 22, right? Because 32 minus 10 is 22. So 22 divided by 4, it's just under, let's see, 22 divided by 4. Oh, 24 divided by 4 is 6. 20 divided by 4 is 5. So we're going to need between 5 and 6. The numbers between 5 and 6 in the 4 bins. So that should be between 5 and 6. All right, so this is where it can get a little bit complicated, but you can make your own decision for these ones. There's more mathematical ways to do it. Get down to the decimals, but I can't really put like decimals in there, so I need to make a decision. All right, I'm just going to say that I need to cover all of it, right? So I can make the between 5 and 6. It's like 5.5, right? So we'll see what happens if I go to 5.5 and see if I run into any issues. So my first bin would be 10 to 15.5, 15.5. This might actually work out pretty good. Okay, so 10 to 15 effectively, right? That's my first bin. I'm going to call it bin A. All right, just so that makes my plotting easier. You can keep your bin 10 to 15.5 if you want to, but that's fine. You don't have to, right? But as long as you know that your bin is between 10 and 15. So how many between? So then I'm going to need 5.5. So it's going to be like 16 to, let's see, 5.5 plus 5.5 is going to be 21. 16 to 21. That's going to be bin B. All right, and then 21 to 5.5 is 25.5. No, 26.5. So 22 to 26.5. 26.5 is going to be bin C. And then bin D is going to be 27 all the way up to 32, all the way to 32. So that worked out pretty good. Okay. Gives us a pretty good variation of the numbers that I have. It's going to be bin D. All right, so now I just got to count the number of things that would go into this bin. So I'm counting the things between 10 and 15. Okay. So inclusively. So 1, 2, 3, 4, 5, 6. There are 6 in there. Then 16 to 21, there's 1, 2, 3, 4. There's 4 right there. Okay, and then 22 to 26, 23, 24, 25, 20, there's 3. 23, 25, and 26, and then there's 3 in this one. Okay, so now I can make the frequency, the number, the number amount of times that these numbers in these ranges show up versus the number of times, right? So this is the number, the frequency. It's the frequency that these numbers showed up, and then these are the bins. So we'll say there's 2 ways to do this, right? I like to do it the first way to do it is to show the distribution of the data, like the shape of the distribution. This is already going to show the distribution, but this will say the shape of the distribution a little bit better. So if you take A, which was 6, this is my lower end one, and this one all the way up to 6. Say that this is 6, right? And let's make a straight line, I guess. So this was all the way up to 6. Okay. Bin B, it was 4. A, B, C, and D. Bin B is 4. So grab that guy. It's going to be down here like 4. And then this was 3 and 3. Let's make that a little shorter. 3 and 3. Okay, so this is what the data kind of looks like. Okay, the distribution of the data. Right, over here is 4. Oops. Over here is 4. And then these are 3 each. Okay, and you can see that the data kind of looks like this. It kind of looks like it could be an exponential decay, right? Or something along those lines. Okay, that's one way to show the data. It shows the distribution shape of the data. Another way to do this is, let me go back a little bit, is to place it and put another axis on this side. And this will be relative frequency, the relative frequency in percentage. Okay, and then we're going to go from smallest to biggest. So C and D are the smallest. So we have C and D were the smallest, followed by B, followed by A. Okay, and then it's going to look like we had it before with some lines. We had C at 3, D at 3. Okay, let's see, B was at 4, and then A was that would be 5, so A was at 6, like that. Right, so the data distribution now looks like this. Okay, and it shows 2 pieces of information. It shows the number over here, where we had 3, 4, and 6. If you read that one, you could also put the numbers like next to the bar. And it also, if you do something like this, okay, this shows you the percentage. It's actually going to be more like, okay, this shows you the percentage of the whole, right, over here on this side. So if you were to take this dot and move it over here, it would show you that percentage. This dot over here would show you that percentage and that percentage, right? So that's what this is going to show you. And this up here would be whatever, 6 divided by 22 is that percentage. 4 divided by 22 is like 5 and 4.5, right? That would be right there. And then That would put your percent relative frequency right here. Okay. Remember, your relative frequency is the number, the frequency of, like, this is the relative frequency of A, right? Relative frequency, but divided by N, which is the number of things, right? So 6 divided by 16 is like, uh, let's see, divided by 2 is 3/8. Like 3/8. So 3/8 is like, let's see, 1/8 is, what's 3/8 in percentage? I forget. 0.125 times 3. So let me pause this and do a calculator real quick. And that's 30.375, which is 37.5%. 37.5%. Right, so 37.5 for the 6, well, that's the majority of it. And then, 4/16 is 25%, right? And then 3/16, let's see, 3/16, 3 divided by 16 is like 18.75% times 2, right? So that would add up, all that should ideally add up to 100% if you did all the math right. Right, so that is a histogram, and I love them. They're great. Oh, wait, we need to go over the table. Yeah, so here we have the table. Let me pull it up and post it here. I'll put it like right here. Okay. All right, and then let's look at which one of these did what. Okay, you might remember that this shows distribution set, right? So these both show the distribution sets, and so does this one. This one shows the distribution of the data set in two different ways, right? With relative frequency and without, and just with regular frequency. Okay, this one shows the shape. Yep, that shows the shape of the distribution. Does it use bins? Yep, does it use bins? Right, displayed in intervals. Yes, this one uses bins. The other two did not. The other two, however, also did all that. Okay, so this is where it starts to differentiate. Okay, and this one does it show each individual value? Remember, we're just looking at this. Right down here would be the actual numbers. Over here, I just didn't write that because I don't want to make it messy. Right, but no, this one doesn't. Um, Unlike the line plot, which did show the actual values, the histogram does not. Similar to the box plot, does not show it. And does it show the 5 numbers set summary of the data? Does it show the mean, the median, and all that stuff? No. The only thing that does that is the box plot. Right, so that's what this table is looking like right so far. Hopefully that makes a bunch of sense, and we'll move on to our last univariate data, the stem and leaf.